Today we're going to go over curve sketching. This is very important as it shows up a lot on the Calc 1 AB AP exam often, or any Calc 1 college exams. Curve sketching is a very useful tool to have because you can take any function, kind of difficult, something that you don't normally know. You can't just look at it and be like, oh, that's a parabola, right? You take any function and you should be able to figure out kind of how it'll look. So let's go ahead and solve this problem. So we're going to start with step 1. Let's find the derivative, right? We want to find where the function increases or decreases. The derivative correlates to slope. So if we find the derivative of this, we can see where there's a positive and where there's a negative slope. All right, so step 1 is take derivative. So the derivative of x cubed minus 3x squared is just 3x minus 6. Sorry, 3x squared minus 6x. And I'm going to simplify this a little bit just because I don't like working with the squared, kind of like that. We can factor out a 3x, and we're left with x minus 2. All right. Now that we have our derivative equation right here, let's find our critical point. Critical point tells us where the slope changes from increasing to decreasing, or decreasing to increasing, right? Something fun happens at these points. So we got to figure out where that is. So step 2, find critical points. All right, and in order to do that, we just take our derivative and set it equal to 0. So right where slope is 0 is usually an indicator that slope is changing, or it doesn't exist. But in this case, it is changing. So from this, we can see that we get 2 answers that complete this form. We can either move this to this side and have x is equal to 0, or we can move 3x to this side and get x is equal to 2. So these right here are our critical points, right? Super fun. So now the fun part. Now we need to know, so now we know where the curve changes, where the slope of the curve changes from either increasing to decreasing or decreasing to increasing, but we don't know if it's going from increasing to decreasing or if it's going decreasing to increasing. All we know is where there's a change. So step 3 is let's find out what that change is. So we're going to test if increasing or decreasing, right? To do this, we know our critical points of 0 and 2. So we're going to pick a point slightly to the left, right, and slightly to the right of each critical point to see, okay, at the left, what's going on? At the right, what's going on? So let's start with x equals 0. So we're going to start with, x, a number less than 0. So we're going to say, and we want to do it very close. So I like to go just, we're going to say, let's go with negative 0.1, right? Make it very small. So we plug this back into our, derivative formula. So we have f prime of negative 0.1 is equal to, right, we have 3 times a negative 0.1 times x, which is negative 0.1 minus 2. This becomes a negative times a negative, and that is a positive. So at negative 0.1, we have that it's increasing, right? That's kind of a quick way I like to do it is if I have anything multiplying, I see, okay, this becomes a negative times this is also a negative. A negative times a negative is a positive. So I know that's increasing. I don't actually need to find the value. I know that right to the left of 0, it is a positive slope. So now let's find in between 0 and x. So in between 0 and x, oh, sorry, 0 and 2, I'm going to choose 1, make it nice and simple. So f prime of 1, you have 3 times 1, 1 minus 2. This yields a positive times a negative, which is a negative. So in between the two critical points, it is decreasing. And then let's pick a point right above 2. So we're going to say, so above 2, I'm going to choose 2.1. The reason I'm choosing a smaller number like this instead of, say, 3 is because there's a lot that could happen between 2 and 3. So I like to go as close to the number as possible. 3 works as well here, but it's always good practice to go as close to your critical point as possible. So we have 3 times 2.1, 2.1 minus 2. This yields a positive times a positive, which is positive total. So above 2, we have that it's increasing. So based from this alone, we know that our slope is increasing up until we get to 0. Then it's decreasing until we get to 2, and then increasing again. So it looks something like this for now. But we still don't kind of know where any other points are. So next step is to identify the maximum and the minimum of the function. So what are we on? 4? Step 4, find max and min. So at x equals 0, the function goes from increasing to decreasing. So this right here becomes a local max. And then at x equals 2, we go from decreasing to increasing. So this becomes a local minimum, right? But we can't find the absolute max and min because we don't know that yet. So let's determine concavity, right? And in order to do that, we need to take the second derivative. So step 5, concavity, check. So again, to do this, we take the second derivative. So f double prime x. And the second derivative is just taking the derivative of this right here, of the original derivative. So 3x times x minus 2 is equal to d dx 3x x minus 2. We can rewrite this as 3x squared minus 6x. So this becomes just 6x minus 6. So this right here is our second derivative. All right, now that we have our second derivative, let's find the inflection points where it goes from concave up to concave down or vice versa. In order to do that, we need to set it equal to 0. So step 6 is find inflection points. And we just take the second derivative, set that bad boy equal to 0, and this yields x is 1. So at x equals 1, something happens, right? But we don't know if it's concave up, concave down, what's going on. We just know there's an inflection point here. So step 7, let's test the concavity. And this is very similar to what we did in step 3, we find points right before and right after x equals 1. So before, we're going to say x equal to 0.9. Plug that in. We have 6 times 0.9 minus 6. This actually yields a negative number, right? So this means concave down. And what concave down means is, right, like this. It is, the curve is facing downward. It is, you can also think about it as the curve makes a frowny face. I guess that's a frowny face right there. And then let's check at right above x equals 1. So we're going to say x is equal to 1.1. So 6 times 1.1 minus 6, that it yields a positive, so concave up. And sorry, please ignore this. Oh my goodness. Please ignore that. All right, so we know that before x equals 1, the curve is concave down, and above x is equal to 1, the curve is concave up. So now let's plug in x values into the original function to find our key points. All right, so step 8. Find key points. So we have x is equal to 0, x is equal to 1, and x is equal to 2, right? So these two are critical points, and this is the inflection point. So these are our key points. Let's plug into the original function. Right, we want to find our y's for those parts. So the original function, again, is x cubed minus 3x squared. So x cubed minus 3x squared. So for x is equal to 0, you get y is 0. For x is equal to 1, you get y is equal to 1 minus 3, which is just negative 2. Sorry, I had a brain fart there. And then x is equal to 2, we get y is equal to 8 minus 12, which is negative 4. So at these x's, we have these y components. So now let's kind of put this all together. So we're going to draw a little graph, kind of like this. So at x, so we have a point at 0, 0. I'm going to draw in blue. We have a point at x 1, negative 2. So 1, negative 2. And we have at 2, negative 4. All right, and we know that the function is increasing before x is 0, right? We have that, yeah, here. So before x is equal to 0, we know that it's increasing. So I'm just going to draw, it is increasing until we get to that point. It is, we also know that it is decreasing between 0 and 2, right? Between 0 and 2, we know that it's decreasing. We know that it is increasing again after 2. So it increases again. We know that there is a local maximum at 0, 0. We know the local min is at 2, -4, right? This is your max. This is our minimum. We also know that it is concave down before 1 and concave up after 1. So concave down kind of looks like this, and concave up looks something like that. So that is essentially, and we're going to put the arrows on them because they go on forever. There's no end value. So that is how to draw a curve of any function, right? We started off from something like this, where you can't just visualize it immediately, but using everything we learned from Calc 1, we can visualize any type of function. Yeah, hope that helps. Good luck on your future exams, guys.